of them. This is a turbo type muffler, and this one here is a straight through or an absorption type muffler. We'll talk about the absorption type first because it's probably a little more simple to understand. So the important thing to note here is that when we're dealing with mufflers, we're dealing with two different things. One of those things is the movement of exhaust gas. So for example, on this system here, we have exhaust gas coming along the pipe here, flowing all the way through the muffler and then continuing on its way. So that is a movement of gas, an actual physical flow of gas along the pipe. The other thing that we're dealing with, and the more important thing for the muffler, is we're dealing with the sound waves, pressure waves, which are traveling inside that gas. So it's important to understand that the flow of the gas is one thing. We want to maintain as much flow of gas as possible. We want minimal restriction on that flow of gas, but we also want to reduce the sound waves. So the sound waves and the flow of gas are two different things. And that makes sense. If you think about listening to the radio outside, the sound of the radio is not blown away in the wind. It travels through moving air because sound waves travel at the speed of sound. The pressure waves of the exhaust are also sound waves, so they travel at the speed of sound. The speed of the exhaust gas flowing through this system will vary depending on the amount of gas flowing, the revs of the engine, and so on. So that's important to bear in mind, that difference between gas movement through the system and sound waves being moderated, changed, altered in whatever way is happening inside the system. So there's two ways that the muffler will reduce or affect or change the noise, those sound waves inside. One of the ways is absorption. So this is an absorption type muffler, or a straight through type muffler, or a glass pack muffler, and that affects noise by absorbing it into some sort of soft material, so basically a glass fiber like insulation. This is in fact insulation because the glass fiber that's inside here is all broken down through age, but you can just about see the strands. So what we have in this muffler is a pipe that runs all the way through, which is perforated. Now the gas itself will mostly flow along that pipe, so we've got minimal restriction, but the sound waves and some of that gas escapes through all these perforations into this packing material here, and it is absorbed by that packing material. In physics terms, what happens is that sound waves, the energy in that gas, the movement of the gas, vibrates this packing material, converts it to kinetic energy in the vibration of these strands. That kinetic energy is converted into heat, which escapes through this system. So that is absorption, which is one way of reducing the sound waves. The other thing that happens in here is that as the sound waves come through, if we imagine our sound waves coming out of the pipe here, they travel into this insulation material here, and all the way along, those sound waves are all jumbled up and they're knocked out of phase, and then when they rejoin the pipe later on and they join that main flow of sound inside, these waves that come out of the insulation knock the main waves, they knock into them essentially, and because they're all out of phase with each other, there's a noise cancelling effect there. The other way of reducing or changing sound waves is through reflection, which is what happens in this muffler. So in this muffler, this turbo design, gas flows in along this pipe here and it flows into a chamber here, and as the sound waves come out through here, they bounce around from side to side off all these baffles that are inside, and those sound waves in a correctly designed muffler will bounce off and collide into each other in a thing called destructive interference. What happens is, let me get the whiteboard. So we'll get the whiteboard into play here. Now, if we imagine we have a sound wave, let's draw some axes here. There's a sound wave there, we have another sound wave. What happens is our first sound wave is moving along like this. We have a second sound wave which is moving along in the opposite phase. Now, these two waves are traveling separately. If we join these two waves together, if we collide them into each other, what happens is they overlay each other like this, and that sound wave will cancel itself out. So this peak cancels this peak, we end up with a sound wave there, this peak cancels this peak, so we end up with a flat sound wave. That's what happens inside noise cancelling headphones. So in a noise cancelling headphone, the microphone listens to the sound around you and then plays the opposite wave of that sound into the headphone, cancelling out the noise from outside. What's happening inside a muffler like this one is that these baffles are designed to reflect the sound waves into each other, causing the peaks and troughs to coincide with each other and cancel each other out. Destructive interference of waves. So that is what's happening inside here. Let's finish off with our straight through type muffler absorption type here. So this is the least restrictive in terms of restricting exhaust gases flow through it, but it's also the least effective at reducing noise. And essentially it works the same as what we've got in the studio here, where we've got soundproofing, soft absorbent material on the ceiling to cut down on the amount of noise bouncing around in here. Same principle at work inside here. So let's get on to this, which is a turbo or a reverse style muffler, and this is the most common on vehicles because it's the most effective for reducing noise and not too restrictive in terms of creating what's called back pressure. So back pressure is where we have a restriction in the exhaust system which causes exhaust gases to build up along the exhaust and creates the gas is building up there at the exhaust port, and when the exhaust stroke happens, it's fighting against an area of high pressure, and that can cause some exhaust gas to remain inside the cylinder when the cycle goes back around and we're back on the intake stroke. Now, we don't want exhaust gases in the cylinder for two reasons. Firstly, they're taking up the space that could be used for air and fuel, so they're giving us less space to put air and fuel into the cylinder, so we get less performance from the engine. Secondly, those exhaust gases are hot and they cause the intake charge to be heated up, to warm up, and warm intake air, as we've seen, has less density, so we've got less of a concentration of fuel and air and hence a weaker mixture. So on two fronts, back pressure in a naturally aspirated engine, that is an engine which is not forced induction, doesn't have a turbo or a supercharger, a back pressure in the exhaust system is a bad thing for a naturally aspirated engine. Now, on a turbocharged, a supercharged engine, that could be a different situation because the intake gas is entering under pressure and not just being sucked in by the movement of the piston. So this will create some element of back pressure, but it is also incredibly efficient at reducing sound. So let's take a look at how this thing actually works. So it's called a turbo. I don't know why it's called a turbo muffler, but I know why it's called a reverse muffler, because the air, the exhaust gases flow back on themselves in a kind of reverse situation. So if we imagine our exhaust gases are coming along here through this pipe, working their way along the system here, they come into the muffler here and they work along this pipe. So what we can immediately see here, although it's tricky to actually tell the difference between holes that are intended in this pipe and holes that have appeared through rust. But anyway, we have a number of perforations in this pipe of a certain size, a certain spacing, and these are carefully engineered perforations. So some of the exhaust gas and some of the sound waves will travel through these perforations and into this space here between two baffles. So we've got baffles inside here. The outside of this muffler is called the muffler jacket, and the internals here we have baffles. So between these two baffles here is an area that some of that very first exhaust gas will escape into, and we have sound waves in here. Majority of that gas will continue along this pipe here into this area here, where we can see that the pipe ends, so the majority of gas will come in here, and it will bounce around inside between these two baffles here, the sound waves cancelling off each other, destructive interference going on to reduce certain frequency. So the spacing of these two baffles has been determined to cancel out a certain frequency of exhaust sounds. Some of the gas will also enter through a hole here that we have in this baffle into this area here. Now there's no exit from this chamber. If you were to look at this baffle, there's no other exit from this. It simply has a hole here. So this is what's called a Helmholtz chamber. We've seen one of those on the air intake. This is here just to create an area of vibration. This will alter the tone of the exhaust note by basically acting as a reservoir of air, creating some sort of resonance in here. But the majority of the exhaust gases will come into this chamber, bounce around, and then they will enter what used to be a perforated pipe here. So we can see, this is like an autopsy basically. We can see that there was a perforated pipe here. It's rusted away, but the majority of gas would have gone in through those perforations here and would have travelled along this pipe, which would have been, you know, in ancient times, would have been an entirely intact perforated pipe. The exhaust gases would have travelled along here, through this baffle, into this area here, where there would be another resonance acting, another cancellation, more destructive interference of sound waves bouncing off these two walls, and then that air would travel along this pipe all the way through the muffler right out to here, which is heading out to the tailpipe. We would have had a tailpipe right here. So we can see perforations. We have a second set of perforations on this pipe. So our exhaust gas has come in through here, bounced around in here, entered this perforated pipe, travelled through here, bounced around inside this chamber, gone into this main exit pipe, and on this main exit pipe there are also perforations. Different size, different spacing. Designed for a specific frequency, a specific amount of exhaust gas and a specific frequency of sound wave to come back into this chamber and resonate around and then out of the system. So you can see there's an enormous amount of engineering gone into the spacing of these, the spacing of the perforations, the amount of perforations and the size of those holes. All of that comes into play in reducing and altering the exhaust note that comes off one of these turbo reversible mufflers. Now, since we're in on this autopsy, what we can see actually in this last chamber is that this pipe was actually surrounded by glass fibre, some sort of absorbent material. I suspect that there were perforations, and this final section of exhaust was acting like a straight through pipe inside this turbo muffler at the back here. So we had kind of both effects at play at once in here. One thing that's important to note on this muffler is if you take a look at the outside of this is actually in pretty good condition. Is the inside where the majority of the corrosion is. This muffler has effectively rusted from the inside out, which is not what you would expect, but there's a reason for that. What happens is that water is a byproduct of combustion. So in the combustion chamber, when the fuel and air is ignited, water vapor is part of the exhaust gas that comes out. Now at those high temperatures, obviously that water is steam, and that travels along the cold exhaust system. When the engine starts up, it takes a while for the exhaust to heat up. So the steam will condense as it travels down the exhaust system, and the muffler, being the final part of that system and the furthest from the engine, will tend to stay coldest for the longest. So water vapor will build up in here until the muffler gets up to over 100 degrees, and that water vapor turns to steam and then travels out with the exhaust gases. So on a vehicle which travels a lot of short journeys, which looking at this muffler was the case with this car, this may never get to a temperature where the water boils, so water will build up inside here. Now on some mufflers, and I don't think on this one has them, there are pinholes at the bottom of the muffler to allow the water to escape. I know we've got a pinhole like that on our new muffler here, just at the bottom. This is there to allow any water vapor that's built up inside there to escape. And that's why mufflers tend to corrode from the inside out. They also, of course, corrode from the outside in on salty roads and so on. They have a hard life, these things. So with a turbo muffler, a reverse muffler like this, we have a gas flow that comes around in an S shape effectively, or some sort of spiral shape. The gas isn't travelling in a direct way. This will create the most back pressure of the mufflers. Now there's a different type of muffler which from the outside looks very, very similar to this, almost identical, which is what's called a chambered muffler. So in a chambered muffler, the exhaust gas comes in here and it travels through a series of baffle chambers just as we've got here, and then out of this side. It doesn't travel in this S shape, it travels through the chambers. Now a chambered muffler will reduce the sound less, it will leave a more of a deep rumbling exhaust, but it has less restriction, creates less back pressure than this design, which creates the most of all of them. One final thing with exhaust systems is that there are what's called active exhaust systems, which have flaps or valves on the exhaust, which allows the system, the vehicle, to vary the exhaust sound depending on the driving conditions of the vehicle. So driving quietly, for example, on Aston Martin, they have an option to reduce the sound of the engine so that you don't wake the neighbours when you start the engine. You may also want a louder exhaust note or less restriction in the exhaust system if you were racing, for example, on a track day. So you can buy these exhaust systems as aftermarket parts, and actually BMW used to make one. In fact, I think they still make it, but they can no longer sell it in the EU because the EU have passed some laws which make two things illegal. It's now illegal to produce and sell an aftermarket exhaust which is louder than the system that was fitted to the vehicle when the vehicle was approved. And the second thing that's now not legal to have is a form of control inside the vehicle which allows the driver to increase the sound of the exhaust, again, beyond what was approved. So BMW used to make this active exhaust system for its M3, its M5 type vehicles, which had I think is a button inside the vehicle which you could press to activate sports mode that would open some flaps and bypass one or more of the mufflers on the exhaust system. That is now no longer legal to sell or manufacture in the EU. I guess they maybe still sell that in the US, I have no idea. That is exhaust systems. The end. Weekending there. Come over to howcarworks.com where I have a whole 20 hours or more, probably by the time you watch this, of videos that explain every part of a modern car and take you step by step from knowing nothing to knowing more than nothing. It's a brilliant series, you'll enjoy it. Join me over there.